Hi, in this lecture we will see what is the top view of a binary tree and how we can implement it. So this is a kind of interview question which is commonly being asked, and it is kind of medium to easy kind of interview questions. If you know, then it's an easy. If you don't know, then it may become tough for you. Even it can be considered as hard if you don't know or you have not done. So if you talk about what is the top view of this binary tree, then you can see that 11 is coming. If you are looking from the top side, then 5 will be coming, then 2 will be coming, 7 will be coming, and 21 will be coming. This is what I have written here. That is 11, 5, 2, 7 and 21. 6 will not be coming because 21 is above it. So if you look from the top, so 21 will be there. 9 will be not coming because 7 is at the top. Simply 4 will not be coming as 5 is on the top of it. So this is what this tree represented above will look like if you look from the top. That is 11, 5, 2, 7, 21 if you go from the left hand till right hand side. Now the key concern is you need to store horizontal distance considering 2 at 0th node, or you can see 0th distance. If I go till 5, then I can do a subtraction. So 5 will be minus 1 distance from the center, 11 can be minus 2 distance from the center. Simply if you are going from the right hand side, then 7 will be at plus 1 distance from the center and 21 will be at plus 2 distance from the center. 9 will be at plus 1 because 7 and 9 are in parallel, and 21 and 6 are at the same horizontal distance, so 6 will also be at distance 1. If I put horizontal distance only, store horizontal distance only, then it will not be counted in terms of top view because we need to store the vertical distance also, because whatever the node which is coming in from the top, that only needs to be considered. So if 5 can be considered if I am going from the bottom side from the top, then the node which is coming in the bottom will be counted with plus 1 distance from the above node. So if I put 2 as 0th distance from the top, then if I am going in the, not in the horizontal, but this time if I am going in the vertical direction, then 5 will be addition from the of 1. So 1 distance 5 will be coming, 2 distance 11 will be coming, and at 3 distance this 4 will be coming. Simply 7 is at 1 distance, 21 is at 2 distance, 9 at 3 and 6 at 4 distance from the top. So for printing either bottom view or a top view, you need to store both horizontal and vertical distance. So for storing this horizontal and vertical distance, I need a map. So I'll simply call a map. Either you can put map inside map or you can put array inside a map. So I'll put integer. So it will be a kind of integer only, and I will store the data along with the vertical distance in an array. So I'll put int array type, and I'll name it as map only, and it will be new. And I need to print the in an ordered way, that is from left hand side till right hand side. So I'll not use any hash map, I'll use tree map. So tree map will be there, and I will call a utility function. So I'll write print top util. Inside that I will pass this head node which has been passed, and also map will be there. And to store the horizontal distance, I will pass the horizontal distance of root node, that is at 0th index, and also the vertical distance which is at currently at the 0th distance. The 0th distance for horizontal and vertical I am depicting for root node, that is at 2. So I need to create this utility function. I will create through IDE only, and whatever the operations I need to perform, I will perform here. So I will simply go and write the code. For writing code, first thing needs to be considered whenever you are writing it any tree data structure, you need to consider the edge cases. So edge case is head equals null, then simply just return. Now you need to check whether any data I am putting in the key part as horizontal distance. So I need to check if any data is available in the map with that horizontal distance or not. So I'll check if map dot contains key the horizontal distance. I'll put HD, and instead of I will write this HD to be more clearly visible, and J as vertical distance. By default it has taken ij. I'm just renaming it. So map contains this horizontal distance. I put not here. So if map does not contain, then I simply need to put it here. Map dot put, and I'll put horizontal distance as a key. And to store the vertical distance, I'll store along with the nodes data. So I'll put new int. I have taken array data structure in the value part. So I'll store the value of vertical distance along with the node data. Head dot data and this vertical distance, because at this horizontal and vertical distance the key was not present. If it is present, I need to check the vertical distance, because already at that horizontal distance, suppose if I look into the map, if already 5 and 4 is present, I'm going traversing for 4, then I need to check from that vertical distance if it is available or not. If it is available, since I am printing top, then the vertical distance of whichever node is less. Here 5 the vertical distance is 1 and 4 vertical distance is 3. So 5 having less vertical distance, so I need to store that one only, otherwise the bottom view will be printed. So I need to check if it is present, then if map dot get that horizontal distance first, then the vertical distance, that is which is present at the first index. This is that first index, as you can see inside the array. So map dot get will give me the value. The value is an array, and this array's first index, this is at 0th index and this is at first index. First index vertical distance is greater than or less than. Since you are going for the top view, you need to check if it is less than, if it is greater than or equal to this current vertical distance, then you need to replace it. So you can simply write map dot put, and inside this you just simply go with that horizontal distance. Just replace the data at the horizontal distance with new integer array, and I need to pass head dot data, then the vertical distance. That's it. And after checking, since existing data was having more vertical distance, as you can see, than this, so I have replaced it with the current vertical distance, because current vertical distance is less, so it is coming above the existing data. So we need to print all the nodes which is coming above, that is the top view. After calling this, I simply need to print, you call this print util function, and in the head dot left node. And now if I am going from left hand side till right hand side, and if I am using tree map, then if I want to store the left hand side data first and print the left hand side data first, I need to put all the left in the negative form. So I will simply call horizontal distance -1, and vertical distance I need to add every time, because we are going in the bottom side only. For horizontal we are going left hand side or right hand side, but for vertical we are simply going in the bottom, that is we are just going to append 1 every time. Again, this is about the left hand side tree. We need to print the right hand side also. So I'll call print top view head dot right, and since we are going in the right hand side, I need to add +1 to the horizontal distance. And what about vertical distance? Just think of it, it is adding every time in the bottom, so I'll just add it. That's it. We have called a map function. Inside this map, I'll check whether it contains with that horizontal distance. If it does not contains, as I put it here, this not is there, then simply I am adding it. If it contains, then I need to check whether this vertical distance, that is first index data, is greater than this vertical index, or you can say vertical distance. If it is greater, then I need to replace it, because this current vertical distance is less, so it is coming in the top. So I need to replace with the existing data, and after that I will call this print function with left hand side as -1 distance from the current node, and right hand side as +1 distance, horizontal distance from the current node, and both of them are moving in the downward direction, so adding 1 to the all vertical distance. This is how we can print this top view of a binary tree. So if I going to print this data, I need to call a print function. Since I have stored everything inside this map, just after calling this print top util function. And after this I need to print the data inside the map. For printing data inside the map, since I am storing the value in form of integer, so I will call int array I, and this will be coming from the map values, map.values. The values are stored in integer array, so I have called the integer array, and I simply need to print the data at the 0th index. As you can see, in integer we are storing the data in the 0th index, so I need to print that only. I will call simply sysout, and ln I am removing because I need to print in the one line only with I with the 0th index, because we are storing data in 0th index, and I will simply call this. After that provide this, or before that I can also write in better way, that is top view of tree is, I can write in that way. And when I will run this, run a Java application, 11, 5, 2, 7 and 21 is coming, 11, 5, 2, 7 and 20. So this is coming from this side, 11, 5, 2, then 7 and then 21 as a top view. So a twist is there. If someone asks that instead of putting left till right, either you can go with right till left. That is, instead of this you go with 21, then 7, then 2, then 5, then 11. Then I can do two things. Instead of putting left hand side in the minus, I can put left hand side in the plus and right hand side in the minus. Then the data will be coming right hand side as a negative data, so the tree will sort this negative data in the start, and left hand side, which is at the positive now, will be coming in the after left and right hand side data. So if I run this, as you can see, 21, 7, 2, 5 and 11 is coming. So if I go to the top, then 21, 7, 2, 5 and 11 is coming. So from right hand side till left hand side, though they are both top view. Other way around is that put this in the original form, that is from left till right, and if you are using any comparator, then it can be sorted. Like if in the tree I itself provide a comparator, that simply you can do to reverse this data which is coming. Instead of sorting from left negative till positive, you just sort from positive till negative. So if I run this again, also run as Java application, 21, 7, 2, 5 and 11 is coming. So we have seen how we can print the top view of a binary tree, and also from left till right and right till left, in both the ways. This is how we can print the top view of binary tree. Thank you.